Welcome back to another one of my videos. Today's video will be a brief walkthrough of how you can set up STM32 in Visual Studio Code. I'm using Linux right now, but the steps are similar for Windows or Mac. If you are not familiar with the STM32 microcontrollers, you should know that they are widely used in industrial and IoT devices. The reason behind their popularity includes a comprehensive ecosystem, robust architecture, and outstanding hardware performance, as they utilize the ARM Cortex-M chips. This also means Arduino and ESP32 are more suitable for hobbyist projects, whereas STM32 is a better option for industrial applications, where you need great scalability and reliability. Now let's move on to the guide on how we can set up STM32 with Visual Studio Code. Look for the STM32 VS Code extension by ST Electronics. Look at the extension description page, and you will see there are prerequisites. I will briefly explain each of them. STM32 allows for the use of ST Electronics proprietary tools within different IDs or code editors. It helps us compile projects and run or debug the application on a specified board. STM32CubeMX is a graphical tool for generating initialization code, which means it can set up pins for our intended purpose, such as GPIO pins, or change the clock configuration of the system. The MCU Finder contains all the data and documentation on different STM boards and can also help you choose the most suitable board for your project based on criteria such as CPU frequency. This is very helpful considering there is a huge number of different STM32 microcontrollers out there, with each one having its own unique strengths or weaknesses. Once you've installed all packages, extract them like this. As I'm currently running Linux, I will go into the extracted folder and then run the shell script. Of course, I've already installed it. The process is even more straightforward for Windows since you run an installer instead of a shell script. Also, you should note down or copy the path of installation path. In older versions, you probably need to download the Java runtime, but newer versions already ship with the Java runtime itself, so you don't have to download anything. If you're using Linux like me, then it is required to install the ncurses library for a text-based interface too. The final step is to set the path of the executable of the STM32 components you have just installed so the VS Code extension knows where to run them. To do so, you go to File, Preferences, and then Settings, where you search for STM like this. For Linux users, please take a look at my own settings here, as you may not know where the installation script installed the components. For Windows users, you only have to look for the executable inside the installation paths, which I told you to copy earlier. Now that you have done the setup, we can start creating our own project. The project today is only about blinking LED. Before we see how to do so in VS Code, I will make some hardware notes. STM boards like the Discovery don't require an external debugger, but for normal boards like Blue Pill or Black Pill, you need a ST-Link to flash the code. Wire the debug pins of the STM32 to the corresponding pins on the ST-Link. Since we are doing LED blinking, don't forget to wire a 1 kΩ resistor to the LED. Click the extension icon and then launch STM32CubeMX, where you will create your project. Next, you will find the board or the microcontroller that you have through STMCU Finder. My STM32 board number is F401CEU6, so I will select it. Once done, you will choose a pin as your GPIO output pin, which I chose PB5 or pin B5. You can also perform modifications to your clock system or change other advanced options, which are not the focus of this video. In the toolchain drop-down box of the project manager, you must choose CMake, otherwise the STM32 extension cannot compile. Now you click on Import CMake and then select the project you created. There should be buttons for compiling, flashing, and debugging at the bottom left of the screen if you do everything as I said. Now you will go to the main source file and look for the user loop. And then add the code for blinking as follows. You click on Build, and there should be no error. If this is the first time you try to flash, then before debugging, you must click on the Upgrade ST-Link firmware button with your ST-Link plugged in. Once done, you won't have to do this step again and just click on the debug button. Congrats, you have successfully flashed the code and you can see the output for yourself. This also marks the end of this video. I intend to do some videos on STM32 along with ESP-IDF content already available on this channel, but due to tight school schedule, I can't upload videos frequently, but I still hope you can support my future videos once they come out.